Hello and welcome back to the session after the break. In this session, we're going to walk through the word generation process on a step-by-step basis. I have 4 slates in front of you that you can see. We've already attempted slate number 1 in the guide that you have available. We did slate number 2 in the morning, but unfortunately that session wasn't recorded well and that recording was no longer available. So what I'm going to do is I'm going to walk through the second slate in this deck, which is WOOTWLU, and try and see the process, the mechanics of using this slate to go out and generate our 2-letter word combinations. Once we walk through the process of generating 2-letter word combinations, it'll be easier for you to see how to extend that. Remember, this is a session that does not use Power Query. This is a manual hands-on session. The objective of this session is not to illustrate the Power Query guide, but to walk you through the mindset and the thinking behind the steps that you've seen in that guide. Ready to start? Let's begin. So our first step is to go out and create a simple column. And in this column, I'm going to zoom in a bit so that we can see the screen more clearly. Okay. So our first step is to go out and pick the first letter. The first letter column is essentially going to be WOOTWLU. This is actually a this is a really complicated case because you've got 2 repeating letters, 2 W's and 2 O's. But let's see how it goes. So 1, 2, 3, 4, 5, 6, and 7. So these are the 7 tiles on my slate, and what I want to do is I want to combine these 7 tiles with their exact replica. I know there are a couple of challenges there in the sense that you're picking up the combinations on assuming a non-replacement, assuming non-repeating tiles, but for the time being we'll simply start off with a model where the first letter and the second letter are exactly the same. We can then refine it and pick the numbers, the combinations that we want out of the ones that we don't want. Okay, so our second letter is exact replica of our first slate, and what we now need to do is figure out how to combine these 2 columns together. So the process, the sequence, the mechanics are fairly simple. What we want to do is we want to look at this W, and combine it with the first letter, then the second letter, then the third letter, then the 4th letter, then the 5th letter, and then the 6th letter, right? So this would give me WW, this would give me WO, this would give me WO, this would give me WT, this would give me WW again, this would give me WL, and this would give me WU. So 1, 2, 3, 4, 5, 6, and 7. And then we're going to repeat this for the remaining 6 tiles in the slate. So if this is column number 1, we'll actually have 2, 3, 4, 5. Let me create space on the side. Okay, 1, 2, 3, 4, 5, 6, and 7 columns. So if you just look at the raw output, the raw combination of 2-letter words that will generate out of this exercise, you will actually have 7 into 7 rows, which is about 49 possible combinations. What we then want to do is, from this list of 49 possible combinations, we want to eliminate the duplicates, we want to eliminate any blanks, we want to duplicate any repeating combinations that would not be possible when we are sampling without replacing the original tile. As I said earlier, this is a special case because in this special case you actually have 2 words that repeat, W here and O. But I want to run through this calculation at least once so that you understand how the process works, and then we can compare it with a slate where there are no repeating tiles. So if we go out and do what we just suggested that we're going to do, let's go out and do that. So column number 1, column number 2, column number 3, column number 4, column number 5, column number 6, and column number 7, and our word choices are, let's just do here, 1, 2, 3, 4, 5, 6, and 7. So WW, WO, WO, WT, WW, WL, WU. That's the first column. This first column is covering this piece. So this W combined with the second letter. Our second column is going to be O. So it's OW, OO, OO, OT, OW, OL, and OU. And that represents taking this letter and then combining it with the second letter. The third one is going to be the same because O gets repeated, and right now we're not cutting out or removing or eliminating repeating numbers. So that's the third one. Our fourth column is going to be T, so it's going to be TW, TW, TO, TO, TT, TW, TL, and TU. Our fifth is again going to be W, so it's going to be WW, WO, WO, WT, WW, WL, and WU. Our sixth column is going to be L, so it's going to be LW, LO, LO, LT, LW, LL, LU. Our seventh and final column is going to be U, so that's going to be UW, UO, UO, UT, UW, UL, and UU. There we go. Alright, so this sequence that you've just generated represents what? This represents your 7 combinations. So this is your first step. This is what I call my raw output. My raw output as it stands is not usable because it has both duplicates and it has the repeating tile, which we need to go out and fix. So we're going to go out and fix that manually for now, and then we'll try and figure out if there is a pattern here that we can use to build something which is more automated. So if I wanted to convert all of this in one sequence, if I wanted to remove and eliminate all the duplicating letters, what's the right way of doing that? The easiest, the simplest way, if you want to do it using Excel, is to just simply copy and paste these numbers here. These combinations here. That's not how you do it in Power Query. That's not how you're going to do it in automated fashion. But because we're taking the mechanical hands-on approach, that's what we are trying to do. So that's WW all the way till here. This is the second column, and then you can actually, if you want, you can actually link it. So this becomes a bit more generic. There we go. So that's the first one here. And then the second column is going to be this one. Not very flexible, but still better than just cutting and pasting by hand. That's 2. And then this is going to be 3. Yeah, that's the third one. So you've got the third one. So control insert, and then 1, 2, 3, 4, 5, 6, 7. There you go. That's the third one. So if I count, this is 21. This should be 21. 1, 2, 3, 4. Extend this. So that's 21. And then after 21, we've got, so this was column M. So we now go to N30. Extend. So 7. Let's take it to 49. We need 49 possible combinations. So we know exactly what we're doing. 45, 46, 47, 49. So remove the last 50, and then, yeah, this was N30. This should be N31. Why is it not given? So if I go to N31, this is, oh, it's not, sorry, that was the wrong one. My mistake. This is column N24. Is this N24? 21. So this should be N24. And then this is N25. We just extend this till we hit a 0. So 21 to 28. Then from 28 onwards, we go to O24. And then we repeat again to 35. And then we go to NOP. So P24 to P3542, and then the last and final one is Q24 to Q30. All right, so you've got your 49 combination, right? So that is now done. Our next step is just cut and paste this as values. So when you do values 1, 2, 3, this simply ignores the formulas and cuts and pastes this. And then for this component, this piece that you've selected, you go to data and you pick remove duplicates, this element, right? The one with the cross against 3 values. Press remove duplicates. It says expand the selection. No, we just want to continue with the current selection. Press remove duplicates. It says column L, so remove duplicates column L, and it's removed 24 duplicate values. 25 unique values remain in this specific instance, and these values are WW, WO, WT, WL, WU, OU, OO, OT, OL, OU, TW, TO, TT, TL, TU, LW, LO, LT, LL, LU, and UW, and UO, and UT, and UL, and UU, right? Now of these, so this was your raw list. This was your raw output. This is your first filter. In this filter, you filtered for what? For duplicates. Now you want to filter for the condition that this is a non-repeatable, non-replaceable tiles. So if you do non-replaceable tiles for sampling, you can't have WW because you can only combine. If I go above here, let me remove this again so that you can see what I'm doing, and this also. Okay, so now in this specific instance, what's happening is that you're saying this set can only combine with this set. So because I've taken the W out and I'm going to combine it, I'm going to only combine it with the remaining 6. Now when I do O, it would cancel this O out and take the remaining 6. If I do this O, it'll cancel this O out and take the remaining 6. If I do T, it'll cancel T out and take the remaining 6. If I do W again, it'll take this W out and do the 6. If I take L, it'll take L out and then do the 6. If I take U, it'll take U out and then do the 6. Okay, fair enough. So if I apply that condition, a clear and simple, easy, no nonsense test is that this needs to be taken out. So all the letters, all the combinations where the same letter is repeated twice is not possible, because that does not meet our sampling condition in this specific instance. We are simply going to mark them out as duplicates. So that's this one, right? How many more duplicates do we have? So this is 1. Then we have OO here, OO. Then we have TT. Then we have LL. And then we have UU. So mark these. So remove these also. And then the question becomes, okay, after these are done, how many samples do you have left? So if you do the non-replaceable conditions, then it's this, it's this. Oh, sorry. It's the next one, which is this one. And if I copy and paste these very quickly, and then I can just delete the ones that I don't want. So I don't want this, so this is gone. I don't want this, this is gone. I don't want this, this is gone. And I don't want this, and this is gone. And this is obviously gone. And then this list itself is my final list of non-repeatable tiles. I simply copy and do a paste special where I paste a value so that I can remove the reference to the cell. There we go, paste special, values are done. So now the formulas have been replaced. Now if I do a count on what's my total output of the 2-letter combination that have been generated, that output is much smaller than the original 49 list produced by the raw output. Let's just copy and paste this above so that we can figure out what the total count is. So our total count in this specific instance, after making all the adjustments, is about 20 words. And how many of these 20 words are actually valid? So if I just do a quick eyeball, I'm not referencing a dictionary. If I just do a quick eyeball, I'd say this one, so OW, and let's mark it. So wait a second. So it's OW, TO2 is valid, low, possibly yes, Lu I'm not sure, UT I'm not sure, UL I'm not sure. So I think we got about maybe 3 words out of our original yield. We generated 49, of which we filtered out about 29. We are left with 20, and of those 20, about 3 are valid. It's possible that when you refer to the original the original official Scrabble player dictionary, it's possible that you may actually have a bigger list of words. But if I just do an eyeball, my take would be these are the 3 that are recognized, and I would think that these are the ones that are valid. So what we've done is we've done a first cycle. In our first cycle, look at the sequence of steps. The first step is what? Step number 1. Step number 1 is take the first slate, use that as your first letter, then replicate that slate and use that as your second letter, and then simply combine the two, and that gives you this combination of raw output. You can extend that raw output and sort it or simply filter it for all duplicate values. Once you've done the duplicate values, you go out and apply the condition for non-replaceable tiles, and then once you have a shorter list of 20 words, on that list you apply your test, your filter for valid words. How do you get to the valid words is a separate question, and we'll try and address that a little later. But for now, I think we've gotten the first step. So now if you've got the first step, how do you go from 2-letter words to 3-letter words? Same sequence. So what we do now next is we take this output, this final output that we've produced here, and I'm going to go out and copy it. So I extend it all the way, go back all the way to the back here, and now I'm going to say my first letter is going to be what? It's actually going to be, so my first step when I want to go out and generate my 3-letter words is to take the output from the first phase, which was 2-letter words, and paste them here. So this becomes my starting point. This is my starting slate. And who am I going to combine this with? I'm going to combine this with the second letter. So my second letter is going to be the slate, the original slate, this slate, the WOOTWLU slate. Fair enough? Okay, so there you go. So this becomes my second slate. And now I think what I want to do is, remember, we're doing this manually, we're not doing this using Power Query. If you're doing it manually, you've got a couple of tools or techniques or hacks that you can use to simplify your calculations. Easy way of not doing all these calculations by hand and using the power of Excel to first simply count how many numbers you need to do. So you need to about 20, and we know this how? We know this because we just copied and pasted these numbers. So this is your list. I'm just going to take this as it stands right now, and I'm going to copy and paste this by transposing it. So this function here, this one that you see that says transpose, it'll take something which is, let's say, in a vertical form and convert that into horizontal, or something that is in a horizontal form, convert that into vertical. Why do that? We'll just see in a second. So in now, what do we need to do? These are my 7, 1, 2, 3, 4, 5, 6, 7 columns. These 7 columns are the columns that I'm going to generate again. I'm going to generate them again. Why? I'm going to generate them again because I need to combine these 7 columns with my word list, with my 2-letter word list. The process, the mechanic, the sequence is going to work. What we're going to do next is going to take this W here, and what we're going to do, we're going to mix it up with the first letter. So WO with wow, so that's wow. WTO, WLO, WUW, WOWO, OTW, OLW, OUW, TWW, TOW, TLW, and so on and so forth. Right? So repeat this calculation. So how does this work? You can take the WOW and combine it with the hands. Just simply type in WOW, WTO, WLO, WUT, OWW, OTL, OLU, OUW, and so on and so forth. Right? So this is one way. The other is you can simply apply the formula, and the formula is going to be simply use the Excel concat function. So concat what? concat this with this, correct? Concat is concatenate, short form for concatenate. So take this word and combine it with this letter here, and that's it. Now, so far so good. It gives you the same result, but the reason why I want to do this formula is that you want to generalize it. You want to make sure that you just type the formula once, copy and paste it, and Excel will do the hard work for you. To do this, you want to make sure that you lock in this cell W, right? How do you do that in Excel? You go in this cell reference. You see the cell reference for X10. You're telling Excel, I want you to lock in this row number 10. So when I copy and paste it, I can go in this direction and I can go in this direction. But when I go in this direction, I want you to stay with this row. If I go in this direction, you can go in this direction. You can change it. But as long as the cell reference concerned, I want you to stay with row. We do that by putting a $ right beneath the 10, right before the 10. So once you do that, now if I press double click, it copies and pastes this, and if I double click it again, it repeats and replicates the combination. You can just do a quick check. This TW should have been TW with W, and that is it. Then TO with W is TO, TL is TLW, TU is TW. So this is fine. The formula works. And then here's the best part. Given how you've done it, you need to make one more minor change, and that change is just like you locked in cell number 10 here. Here you locked in cell number 10. You said this row. When you're copying, when using a reference, use this row. Here, the reference you're going to use is this column. So you're going to use this entire column. So V column. And we do that by doing what? We do that by locking the column V, and we do that by putting a $ before it. So now that we've done this, we once again replicate the formula. It's been copied across the board, and now your work is very simple. You select these 20 words, and what do? You copy and paste them. There we go. So now you have your 3-letter words. This is the raw output for your 3-letter words, and surprise, surprise, this was actually done a lot faster than the first time, simply because we've now got a working formula in place. You now know what the sequence is. The sequence is you remove all the duplicate entries, you remove all the entries that would not be possible if you were sampling without replacing the original tile. And that sequence is clear. That should be clear to you. What I now want to illustrate and demonstrate is how do you generalize this. So now, for example, this piece, as long as I have this piece, as long as I have this list, I can change the tiles and these numbers will automatically get updated. So for example, this number I have, the second letter WOOTWLU, I can simply link it to my original reference. So let's say this is my second letter reference, right? Just link it to this reference. All right, so I've done that. So now let's say I want to replace my WW with what? I want to replace that with AXOPNIU. AXOPNIU, right? So I'm going to put so I'm going to replace this with AXOPNIU. And as you can see in this one, there is no repeating numbers. So this is my first letter. What do I do with the second letter? I simply replace it with, simply link it. I just link the cell reference. So all I did was I just took this and I linked it to this cell, my column K, and I just copy and pasted this across the board. What does that do? Now if you see this component here, our friend here, right? This friend here, this hasn't changed. This hasn't changed. Why? Hasn't changed. Why? Because we haven't generalized the formula. How do we generalize the formula? You remember our neat hack from above? So we just take this AXOPNIU, and what do we do with it? We copy and paste it. And then how do we copy and paste it? We copy and paste it here. We just do a simple transpose. There we go. That's the transpose. For the raw output, I'm going to just move this here. I'm going to copy and paste this reference here directly from AX. So how do we do this? We're going to log this. We're going to log this how? We're going to go to this cell. Simply going to say concat. So concatenate. Concatenate what? Concatenate this. And I want to lock this column. Remember column number I. I'm going to do that by doing a simple $ before the letter I here. So put a $ here. and then comma, and then concatenate what? Concatenate with this number, with this letter here, but lock this row, which is row number 22, and press OK, and that should do it. Concat. Okay, so dollar sign. I wanted a dollar sign K22 close. There we go. So that is A and A, and then what do? I simply copy and paste. There you go. And then what happens? You just take this combination here and copy and paste it here. Alright, so is this correct? Does this work? How do you know? How do you know this is correct? So what are we doing? We're concatenating. We're taking this sequence and building a product with this sequence. We take this A and we're going to take this A, and then we're going to walk it across this list. And where is this list? This list is here. So it's going to be A into A, which is double A into X, which is X, A into O, which is AO, A into P, which is AP, A into AN, which is AN, A into II is AI, and A into AU is AU, right? And then we're going to repeat this with X. So X, also the same thing, same process. X into A is going to be XA, XX, XO, XP, XN, XI, and XU. So this works. Now, so we now have the raw output sorted. What was the next step? The next step was the raw output, and you remember we did a cell reference. We linked all the cell references. We put in the hard work at that point in time. So that hard work has really paid out. It has paid out by going out and generating our combinations. However, I think some of the combinations do we have a U and I? Yeah, we have a U and I. So our last number is UU, IU, and NU. Just check UU, IU, and NU. There we go. This is the last column, right? So it's NU, IU, and UU. That makes sense. So this is fine. Now what do? We simply take this list, copy and paste. So this is the manual step. It's partly automated, not completely automated. Manual step, we copy and paste. What do? We do a paste value. So we do paste special here, and then we apply our data. And what does our data do? Data does remove duplicates, so we remove the duplicates. So we say no, continue with current selection. We've done this, and no, my header does not have header. So column L, press OK. So this no duplicate values were found. I find that hard to believe. No duplicate values were found. They were not found because there were no repeating letters. And because there were no repeating letters, all possible combinations are unique combinations. Is that true? Let's just check. XX, AO, OO, NO, IO, UP, AP, XP. It appears that this is true. We actually have 49 unique words in this specific list, which makes our job a little bit more difficult. Now, the only thing that we need to fix for is the non-replaceable tile, right? So the non-replaceable tile is going to be what? The non-replaceable tile is going to be anything that is double A, anything which is XX. So this number here, so this would be non-repeating. This cannot happen under our sampling conditions, which is we sample with replacing double O will not happen. And so there are going to be about 7 such combinations. Double P is not going to happen. So we will end up with about 42. Double N will not happen. And then we end up with the 7th cell. The W will not happen, right? So those are my combinations. And then what do? So we simply say, give me the first one, which is here. And again, what do I want to do? I want to do this in as generic a fashion as possible. So that gets me to IA, and then I want to not use, so IA is fine, UA is also fine, IA is fine, and UA and AX are both fine, but double X is not fine, so I'm going to skip that, take OX, and then I'm going to take this down again, all the way down to AO, XO is also okay, and after XO I have double O, so double O doesn't work. So I'm going to not take double O, go out and do PO, and then PO I link again to PP. That should do it. So I've done. So PO, NO, And there you go. So don't want pp. So delete this, and then just do np beneath that, which is here. Then copy and paste it again. So this should get you to an n. There we go, nn. Cut nn out, and then for pn, pick up the next one, which is in. Cut ii out. There you go. That's the ii. So cut that out, and then pick the next one, which is ui. This gets you to number 42. IU is the one just before you, right? So that's 42 combinations. And then for our final step, what we want to do is we want to link this output to our second stage feeder. And what is the second stage feeder? Our second stage feeder is this list. So we just go back here and link it across to about 42. Repeat the process for 42 pieces. 42 combinations of 2-letter words from our list. We're now moving into the next stage, which is to go out and do the 3-letter combo. And there you go. So because we've linked this, because we've done this found in such a fashion, this list is more or less ready, except for the fact that we need to copy and paste it all the way down to row 42nd row, right? Right now it's only in the 20th row. You've done this. There we go. So what is this? This is your raw output. So from this raw output, you'd get your 3-letter words. This is your set of 3-letter words. 3-letter valid combinations. You can take these valid combinations and make a feeder for your next step. You still need to make that check, right? What are the two checks you need to? So what this is raw output. You need to remove duplicates. So you would need to go out and figure out if there are any duplicates in this list. So I go back here, and then the last and final step is so remove duplicates. So remove duplicates. The last and final step though is the double condition, right? So now given the non-replacement piece, given the fact that you are coming from this list here, and this list has already one x, XA, right? Remember, this is a 3-letter combination. If the word has been used earlier, then it cannot be used again. So anything that has a double X, a double A, a double O, a double P, a double N, a double I, or a double U would no longer be a valid word, would not be in our list. So an example of that would be, so let's see if I find something here. So you got zo, o, po, no, IAW, UAW, AXW, PXW, NXWI, AOW, XOW, POW, now, ow. Let's see if we have any words that have 2 letters of the same time. So far so good, not as yet. So not here. You'll have to browse through the list. There we go. So that's double O. So these, so all 3 of these, A double O, X double O, P double O, N double O, I double O, U double O, that is a mother load of values that you want to remove. So I'm going to remove these because these are 2 O's. So in fact, rather than removing these, let's just highlight these so we have a sense of how many repeating letters do we actually have. So we highlighted these, and then, oh, there you go. It's not just here, it's here. The infection has spread. There you go. So 2 columns worth of this. So remove this. So highlight these. So I'm going to highlight these and remove these later on in my final list. There you go. And then do we have anything else where we see doubles? Suspicious activity, which are doubles. This is interesting. It said there are no duplicates, but there are duplicates here. I wonder how that happened. Oh, yes, you have duplicates here. You have duplicates here because these numbers, this is not correct. They need to be changed, right? So how do we change this? We need to link this to our friend here. So that's one. That was hard code. That was a hard copy, and that was a mistake. A good thing we caught it, otherwise, our work would have been for naught. That's 2. That's number 5, and that is number 6. U still needs to be linked because when you change the slate, this numbers will change. Okay, so now we have the correct list, and now you can see that yes, there is a difference. There is a clear repeating pattern, and you can use that pattern to, so let me just copy and paste this here. So this becomes my raw output. I do a paste special. This becomes a raw output. You can clearly see that there are double A's, there are double axes, there are double A's, double A's, double A's. All of these words will most likely get knocked out. And then I think the second thing we need to do is we need to figure out some way, some mechanism, some easy way of checking for duplicates across these values. So I think the easiest thing to do is to just sort it out in a linear list and then run the check duplicate function in Excel and remove these. That takes a bit of manual work. But I think you have a sense of how this process works. So step number one is to find out your first letter, multiply the second letter. You can automate part of the process. Part of the process can be automated by creating a structure where you basically create a matrix where you can combine the two. You do the calculations. You can then link that to a raw output. You do a simple mechanical step of copying and pasting it and then generating a list with non-replaceable, non-duplicate tiles. Then that becomes your feeder as a first letter for your second stage, which is to go out and generate your 3-letter words. Once you have the 3-letter words, which is what we've done here in the raw output form, we haven't removed duplicate from this list. We have to do that. We haven't added the conditionality of non-replacing tiles. We have to do that. Once we do that, we'll actually have a list of 3-letter words, and then we repeat the process for 4, for 5, for 6, and 7. This is the mechanical non-query, non-power query version for those of you who had been struggling with the logic, the mindset, and thinking behind the query piece. And that marks the end of our first exercise, which was the manual word generation process mechanics sequence used to generate 2, 3, 4, 5, 6, and 7-letter words. Power Query essentially automates a large part of the mechanical sequencing that we just did here. And if you have Power Query on you, that will make your life a lot more easier and simpler. If you don't have Power Query on you, all it takes is maybe a bit of effort to structure this sheet correctly, and then to structure in such a fashion that when you replace the tiles, you can replace everything in that sequence.